Hi there, welcome back. So this is the last session of our second day of the Jumpstart, if you're watching this live. If you're watching the recording, of course it's, well, whatever it is. We're going to just do a short session looking at how you program SQLite database on Windows Phone. This is kind of curious, if you like, because this is the only session of the whole thing where we aren't actually directly programming something that's in the SDK. This is a third-party package, SQLite, but it is becoming the database of choice for. It's widely used across a lot of platforms and becoming widely used on Windows platforms as well. So, talking about programming SQLite, first of all, when you're talking about SQLite, you need to ask the question: why do you need to use a database at all? And it's worth remembering this because people kind of think, oh, I must use a database for data storage, but sometimes just a flat file is just fine. You know, you just serialize some JSON and store it in a file. You don't need complexity just for its own sake. But where you do need it is where you've got a complex data schema, where you've got a lot of collections of objects with relationships between them. Sorry, I'll go back. So you've got lots of different tables where there might be hundreds of records, and there's lots of foreign keys so that you've got links between one table and another. One column, and a record in one table stores a reference to a record in a different table. You've got these relationships in there. That's the classical relational database arrangement of data. So this is where you've got numerous relationships and constraints. The other one is where you've got a very large amount of reference data. You've got a huge collection of data. That's a good case for a database because one thing a database gives you is efficient keyed access. As long as you've got an index that you're searching on, it can very rapidly go into a huge number of records and go and pick out the records that you want to access. I mean, imagine a dictionary app. What do you do? You know, if you've got thousands and thousands and thousands of words stored in some kind of storage, well, you can't really load all those into memory and do searches in memory. You realistically, you want to have that stored in files and be able to do access. But, you know, you can't do that in flat files. You can't have sort of one file for the A's and another file for the B's and C's and come up with any kind of sensible way of handling that situation. So again, that's a case where you might have maybe a small number of tables, but one of the tables might have a very, very large number of rows. So it's not feasible to have that in memory. So that's another scenario. So once you've decided you want a database, why in particular SQLite? Well, the main reason is actually with Windows Phone 8.1 for Windows runtime apps, we don't have a database. So this is where a third-party package becomes attractive. And this is the world's most popular database, widely used on loads of other platforms. It's very small, and it's an in-process database. So it's not like you've got kind of some kind of database server thing running on the phone. It's actually private to the app, and it's just in process. It's embedded into the app, and it uses it. And it stores it into an ordinary file, so a storage file, which is situated in your local folder. It's not one you'd want to put in your roaming folder. That wouldn't make sense. This would be a local folder for your application's use on that particular device. And of course, it supports all the relational features: multiple tables, indices, triggers, and views. It's very reliable. It's got a large automated test suite, and it is open source. So all of the source, including all the test code, is all available. Anybody can download it and build it. And the other thing is, all transactions are ACID. This means that if the phone dies halfway through doing some updates on the database, your database won't get corrupted. So all transactions are transactional, are completed successfully. That's a crazy sentence. You know what I'm saying? You know what I'm saying? It's been a long day. And it's run by this organization called SQLite.org. They have all the documentation is available on there about the SQL syntax for working it, and the C and C++ API reference. And this is where you get the source and load of tools. So what about using it within Visual Studio for building Windows Store apps for Windows or for Windows Phone? So there is, first of all, you need to get the extension SDK, which are all available for download from the Extensions and Tools Updates menu in Visual Studio, or you can go to SQLite.org, and in the downloads you can find the VSIX files, the .VSIX files, which are the Visual Studio, what does that stand for? Extension SDK.
Visual Studio Extension.
Yeah, and you need to install that SDK, and as you can see on that graphic, there are well, actually, this is a bit of a lie. Okay, so I have had a bit of pain with this presentation, because actually the SQLite for Windows runtime, Windows Phone 8.1, is not official yet. So that version, Tim Hewer has published a blog, and he's done a kind of anybody can get the source. So he's actually packaged up a new extension SDK for Windows Phone 8.1. But it's not actually the kind of gold-plated official release yet. So I'm falling a bit foul with this presentation of the fact that we only released the SDK a few weeks ago at Build, at the time we're doing this live, which is right at the end of April. And so third-party packages and NuGet packages from other tool vendors and libraries such as JSON.NET and that sort of thing, they're all getting upgraded bit by bit. But we're still very early in the life cycle at the moment, so not everything is there yet. And this extension SDK for Windows Phone 8.1 is not quite there. And I did try and build this session around it, but as you'll see when I get to the demo, I had a bit of pain. So you'll have to cut me some slack here. But anyway, these SDKs all get installed down to into C program files, x86, Microsoft SDKs, Windows, or Windows Phone app. Windows Phone app is the new one for Windows runtime apps. V8.1, and so you can see the link at the bottom there. So yeah, SQLite for Windows Phone, which is version 8, SQLite for Windows Runtime, which is 8.0, SQLite for Windows Runtime and Windows 8.1, those are all official. The bottom one there, Windows Phone 8.1, soon will be. Probably in a couple of, we're talking about a couple of weeks' time, but that isn't quite there yet. Now, I just didn't mention, actually these extension SDKs installs a DLL onto your system, which is a native DLL. These are native libraries, okay? So C++ devs can just program against these and use the C or the C++ API published by SQL.org directly against this. They can just go away and program directly against it. If you work with, well, it says .NET, but if you're basically a managed code developer, C# or VB, you need to use a wrapper to access that. You can't, it's a C++ API, so we need to have a wrapper. And there are loads of these things out there. It seems like everybody every week a new one comes along. The one that's there are a couple that are very popular. SQLite-net, SQLite.net is a lightweight. It has a link to SQL-like syntax. So you're using link statements to interrogate table objects and getting objects out of them. But it's still working against the SQLite database as its persistent storage. So if you prefer a link syntax, you want to have a look at that. And that's used by a lot of people. If good old-fashioned, if you like, SQL statements are more to your preference, then there's a couple of wrappers. There's actually one called SQLite WinRT that was created by Peter Torr and shown at Build 2013. I've been working with him and supporting another wrapper called SQLite WinRT. And actually, I spent quite a lot of time last year talking about it. But since recently, a new one has come along called SQLite PCL, which is run by a group in Microsoft called MS OpenTech, who take third-party packages and that sort of thing and get them working, and they do great work. They brought out a new one called SQLite PCL, which kind of does the same thing, works with SQL statements, and in many ways is probably going to supersede the SQLite WinRT one that I've been supporting. So I'm going to concentrate on SQLite PCL for the rest of this talk, but like I said, you have to choose your wrapper, and there are different ways of working with SQLite. So anyway, installing one of these wrappers, SQLite.net or SQLite WinRT or SQLite PCL, they're all on NuGet. So first stage is in your project, you need to add a reference to the SQLite extension SDK. So that brings in the native DLL. That will require you in your configuration manager to change the target platform to x86 or ARM, because I'll show you this in a demo. It just complains, but this is because of the native components in there. Doesn't change anything when you come to submit it. That's all taken care of when you do the stall submission. But you do need to do this in Visual Studio. And then in NuGet, you go and find the package you want, the wrapper, and install that as well. And then you've finally got all the pieces. So here I'm using SQLite NuGet to get the SQLite PCL package. Right, so just a quick look at how you kind of do that. Now, I said there was some pain, and actually SQLite PCL is not available yet for Windows Phone 8.1. So bear with me, because I'm just going to show you how it works, because all of these steps are going to be the same, the code is the same, but what I'm actually going to build is a Windows Phone 8 Silverlight app. So
I have one question that's a little bit off to the side. If someone, a developer, wanted to get familiar with building SQLite databases that would run with Windows Phone, could they start up a Windows RT, Windows 8.1 application, build the SQLite?
Yes.
Are we anticipating that we're looking at the same kind of code convergence there that we see in lots of other?
Oh, totally. Actually, all the code, and funnily enough, my next demo is going to show you just that.
Okay.
I've got a SQLite being used in a Windows 8.1 head, which I could have created here, but I'm going to stick with this.
Okay.
And I've actually got a Windows Phone 8 Silverlight app that is sharing all of the same code through shared files. And later on, when I've got all the bits, I'm going to build out the Windows Phone 8.1 head. Right. So we're kind of not quite there yet. But anyway, in extensions and tools and extensions and updates, we go down. Here's everything that I've got installed already on this box. If we go down to SDKs, along a bunch of Bing Maps and Microsoft Advertising SDKs, you'll see I have got 4 flavors of SQLite. They might actually end up with being 5. I don't know whether they're going to end up with a specific one for Silverlight 8.1. So that one is Silverlight 8.0. This is Windows Runtime Store Apps 8.0. This is Windows Store Apps 8.1. And this one is the not quite official, but kind of have a play with it, one that Tim Hewer has built out for Windows Phone 8.1. But there's no point in me going with that one because I haven't got the wrapper that I need. So, we're nearly there. But anyway, what I'm going to do is choose that's the one I'm going to install. I've installed the SDK, so that puts the DLL into the common area. So I can now add a reference to it. And this is where you go down to Windows Phone SDK, go to extensions, and there's my SQLite for Windows Phone, which is currently 3.8.4.2. Gets revved fairly regularly as they release updates with bug fixes or whatever to the SDK. Now, if you'll notice, I've got a little SQLite for Windows Phone reference here, but I've got a little yellow warning triangle. And this is because I need to go into my configuration manager, and I just need to change. I can't have any CPU. It needs to be a bit more specific than that. So I'm going to choose x86. You could choose ARM. And that goes away, and that allows us to actually debug our app and run it on the emulator, which is an x86 build.
Right.
Right, okay, so, and then I need a wrapper. So let's go to NuGet. I need to go online to NuGet, and I'm going to find the SQLite PCL NuGet package, the portable class library for SQLite. This is the one that is published by Microsoft Open Technologies, Microsoft Open Tech. So it's actually got a bit more support than the one which I do on a best effort basis. I'm going to install it into the solution. This is the one that hasn't been updated yet for Windows Phone 8.1. It will be very soon, but we're not quite there yet. So there's a bit of information about it. You have to accept that you're cool with it. There's a license associated. It's installing loads of other packages as well. So now we've got, oh my goodness, that I wasn't expecting that. I think if I did, 3.8.43. Okay, this is they update NuGet packages, and they've just, this is interesting actually. You get this nice help page. So it actually tells you can go off and get the corresponding SQLite extension SDK. So I'm going to save that as, you need to save it as a .vzix. It comes down as a zip because otherwise it gets blocked. And then you need to change the extension. So I'm glad I showed you this because this is what happens when it gets updated. I wasn't planning on this actually. And then we can install it, which is going to install the new version. It's just bumped up a version. So now we've got 3.8.4.3. So that will go away in a second. We can remove that one. And that should be, we should be good. Go on, let's go and play with me, play with me. Oh. Right, okay, I've got a problem here. Let's just add that one in again. Well, I'm not sure if this is going to work, to be honest. Because I got version problems. It's not a good advert for this, is it? So 3.8.4.3 should have just installed. So actually, if I go off to my C:, program files x86, let's go and have a look what's going on here. Bear with me. Microsoft SDKs. Windows Phone app is WinRT for 8.1. Windows Phone is extension SDKs, SQLite. Oh, right. Where did it put that?
Maybe in SilverLight, the SilverLight 8.1.
Oh, wow. That is odd.
Oh, is that SilverLight or is that Windows Phone?
Yeah, this is the that's the Tim Hewitt one.
Right. No, I thought I saw an 8.1 in the Windows Phone folder.
In the Windows Phone.
I thought I saw an 8.1 option.
Yeah, but I didn't. Was that the one I? No, that's
okay.
because this is an 8.0.
Okay, I see.
So what happened to that VSIX? It didn't quite actually install at all what I was expecting. So that confused me. All right. So I'm going to junk this demo because the next one already works and has got all the right references in it. And I know you could watch me try and fix this, but there are some line. Yeah, thank you for that. Great. Yeah. So he loves doing that.
Thank you.
Yeah, thank you. Because really, actually, you saw the steps, and when your versions of the extension SDK and your NuGet package all align, it's pretty good. And that usually what happens on that help me page, you get the VSIX down. I think I remember reading something on that actually the reference is wrong. I think this is a whole system that's in some flux at the moment, as you can see, and it will all settle down very soon. So anyway, how do you program it when you get it installed? Well, okay. So first of all, what you need to know is that the SQLite PCL wrapper, and this is what I'm going to talk about. SQLite.net does this differently. You create your models and you annotate them, and you do a link to SQL kind of a bit more like the entity framework. So that's more of a, which is it's a nice model. I love it actually.
Right.
But this is more close, really thin wrapper around the SQLite C API. So you're using SQL statements and parameterized queries and statements. Kind of a bit old school, really. But this is how a lot of people like to work with SQL. A lot of people like to work with SQLite like this. So this is how you would actually create a database. You create a new SQLite connection. You give the name of the file. This is going to be the container file, which is just a regular file, which is going to be the container for it. And then you cook up some SQL statements, which are just strings. Create table if not exists, and you're defining a table called customer that's got 4 columns in it, and this is SQL statement. And then you execute it, and the way you do that is you take your connection, and there's a prepare method on that where you prepare the statement, the string, for execution. That gives you back a SQLite statement object, which you then execute with this rather weird method called step. It's always step. This is just the SQLite convention. So step is used not only for stepping through, if you do a query select star from customer and you get back a collection of rows, which makes sense to step through it, but even a statement like this that doesn't return any rows, you still call step. It's just the way it is. Insert, you make your statement up. Again, it's another SQL statement. This is what we call a parameterized statement. So you insert into customer, into the name, city, and contact columns, 3 values, and we've got anonymous parameters in here, which are represented by the question marks in the statement. And then you replace those question marks with the real values by using these bind methods. So you bind into the first question mark a variable called customer name. So customer name, customer city, and customer contact. You've got to imagine those are variables in your app that have got values in them. And you bind to the second question mark a value that's stored in a variable customer city. So you plug in the values into this, and then again you prepare that statement, you bind the values into it, and then you call step to execute it. Select, well, hey, yeah, no surprise, select ID, name, city, and contact. Those are columns from the customer table where, and then got some kind of selection clause where the ID is equal to some value. And again, use statement.bind to supply that value. Then this is where step starts to make a bit more sense. So here we're only expecting one result back. So you can check for SQLite.result.done when it's actually finished and got you a result back. And then we can new it up into our own in-memory object that we can use in our code. And inside the, you see that customer equals new customer? This is how you read the values out of the result that you've been given back by SQLite. It's just you index into the statement. And so you see where we were selecting ID, name, city, and contact, that's statement 0, statement 1, statement 2, statement 3 in the result that you've got back. And you need to cast that to the correct type that you expect. Update, yeah, you update customer, set name equals variable, city equals variable, contact equals variable, where ID equals another variable. Again, 4 bind statements to plug in those values to complete that statement, then step to do the update. And to complete the CRUD operations, delete. Delete from customer where ID equals some variable, supply the key value, and then step to execute. I've got an interesting demo.
I'm already kind of curious that it's not a zero indexed. The binding isn't zero indexed.
Oh yeah, that's kind
throws
of
me
weird.
For a loop.
Sorry, yeah. how long is it since you saw one based collections?
Right.
Yeah, I'm sorry. That's the way it is. Yeah. No, I don't think we need to save that. That was kind of tragic, a tragic demo. Okay, so this weird kind of solution I've actually got in here. I've got a universal app.
Woo!
Yeah, it's got a shared area, and I've got loads of code in there, including some view models, and we'll talk about these a lot in a moment. And app.xaml, which has got some code in here, which does some stuff with SQLite. It creates the database, and then we go off to this method, which is actually in another file here, create database, which is also shared, and this sort of thing, where all the logic is. So here's my statements to create a table called customer, another one called project, and we've got foreign key. So we've got foreign key in project on the customer ID value in here, which references back to the ID column in customer. So we've got some referential links there between two tables. And then we're just executing. So all this code builds my database. And then we've got a pragma, which I'll talk about in a moment, to enforce foreign key constraints. You have to do that. So this is a weird universal project, because you'll notice there is a Windows head, but there is no...
I was looking for it. I did not see it.
Well, actually, it's there. It's
I see.
actually there, but... I've temporarily removed it because it doesn't work. My intention was to show that, and this is what I wanted to show, was actually a universal app using SQLite. And I will, as soon as I have the bits, but I don't have the bits.
But this is interesting. So you could actually start building up your application, having removed the Windows Phone portion of the application, and then you can bring it back in later on using all of that shared code.
Exactly.
Now, I assume that inside that shared code, you can you still switch it from Windows to Windows Phone in terms of the contexts?
Well, yes. I mean, at the moment we're in the SQLite.demo.windows up here. But here's the thing. The other thing that's in this is a Silverlight Windows Phone Silverlight 8 project.
Okay.
An old school Windows Phone app. So this is a Windows Phone app, but not an 8.1 one. But this has got, hey, look at this. It's got create database. See that blue square on it? And view models. So all
Superb.
of these are shared. This is actually all the same files up here. If you've never done this before, what you do is you kind of you say add existing item, and you go off to find a file. So what I did is I went up to the universal, to the shared folder, and I found that create database and selected it. And then if you just do add, it takes a copy of it.
Yep.
But if you do this, add as link, it adds a link to it. So you have one physical copy of the file, and it is shared between. This is how you might share code between a version 8, SQLite 8 version of your app, which is exactly what I'm doing,
yep. and
a universal project. This SQLite demo.shared actually is another way of doing add as link, but but a more formalized and better, easier way of working with it. So it's way complicated, but the point is all of this SQLite code is exactly the same. So I can run this on here, on here, and I've got a menu option to build my database and put some data into it. And then I can go off to another page, and this is and I can go off and find a project that's linked to it. I can go back and select a different one, Tailspin Toys, and that has a different collection of projects on it as one. And there's the details of the project, and we can edit it and this sort of thing. I can let's edit this. It's Windows Store app, for some reason. And then we can save it and go back. It's a Windows Store app, and that sort of thing. And it's being persisted in the database. And obviously it's persistent, so we can close the app, and then we can run it again, and all is good in our demo, and the data will be there this time because it's stored in the database. And what was it, Tailspin Toys, and of course the projects. It's still a Windows Store app, so it's all been persisted away. Now the logic to do all this is all encapsulated in the view and view models. So I'll leave you to study the way that works. But this is kind of an introduction to working with SQLite in a proper database. I do have the this guy, the Windows one is running as well. Debug start new instance of that. So this is exactly the same database handling code. So we have nothing at the moment, so we can reset data, and we've got some data. It's not particularly pretty, but there we go. And we've got some projects, none for that one, we've got one for there. So it's still exactly the same database handling code is working in both the Windows 8.1 and the SQLite 8.0 app. Just a quick thing about transactions, relations, and other constraints. So any change that you make to SQLite database happens within a transaction. I said everything is ACID. It's I forget what that stands for, but it basically means interrupt it and no damage is done. Now, even if you don't explicitly declare a transaction, so you're only doing one statement, like I was doing with .step, it actually declares it automatically wraps it in a automatic transaction. But you can manually have a series of statements that you can say, I want all of these statements to execute or none of them. So I want these changes to be, persisted for all of them or not. And the way you do that is you execute a begin transaction statement. You then have a bunch of statements that modify the database, and then finally, when you're ready to commit all of those as a block, you can say commit transaction, and then you know that all of those changes will be applied at the same time. Or you can roll back transaction, and none of those intervening changes will have changed the database. So that's important, where you've got you've got changes to two different tables that need to be made together.
Right.
So relations between tables as well are interesting. So this is where you have a parent-child kind of relationship, and a customer owns a number of projects. And you saw a little bit in the way the table was made up. You actually have basically a project stores inside it the customer ID of its parent as an item,
right.
And then we have this relationship going on. And the way you define that in SQL is you define a table called, here we've got the table project statement, which has in it a column called customer ID, and that's where it stores the ID of its parent customer record, the key value for its parent customer record. So it allows you to do things like find all the, select star from project where customer ID is equal to 3 or whatever, and it will just bring back the corresponding records. And that relationship is defined by this foreign key constraint, which is that last bolded line on the screen where it says foreign key customer ID references customer ID. Now, the interesting thing about SQLite is that you can put those kind of constraints into your create table statements as long as you like, but they actually will make no difference whatsoever unless you remember to do this, which is to turn them on. They are actually disabled by default. SQLite's been around for so long that when they've added new features, they've often sort of said, well, you know, foreign key constraints are pretty nice. Most people would say they're essential. They're a pretty nice thing, but they're kind of new, newfangled, so we're not going to turn it on. If you want it, you have to say, I want it, which means you actually execute this pragma. So you've got pragma foreign keys equals on, and that's just another statement that you execute. And actually, I think you saw that in that demo that I did at the beginning of the demo.
Now, that has to be enabled at runtime all the time? Every time?
Just put it in your startup, your onloaded logic, just to say, yeah, turn it on. Yeah, so it's at runtime. So if it's not a persistent setting. There are a bunch of other constraints. Primary key, you kind of get that all automatically in a create table. Unique enforces unique values. So every row in that particular column, you can say in this particular column, all the values have to be unique. Not null prevents null values being stored. And then check is you've got a little an external expression you evaluate on every insert that will be applied, that can block a insert if it fails the constraint. See the docs on SQLite.org for more details on all of those. The other weird thing about SQLite, or interesting if you like, is that actually you can store anything in any column. Yeah, I know. You can say create table project and have a customer ID that's integer and another name column that's varchar 100, but then you could come straight away and go insert into project a real value and a Boolean. And SQLite will go, really? You want me to do that? And all it does, and it'll say, it will try its best to convert what you give it into the appropriate format for the column type that you've declared. But if it can't do it, it just goes, huh, okay, whatever. And so this feature is called type affinity. It's kind of weird. Basically, the classical example, if you have a column of type integer and try and insert a string into that column, SQLite will kind of do an int.parse on it to try and turn it into an integer, and if it can't, it will just store the string. Now, there's not many application usages for this, but it does allow you to have a kind of a sort of almost a what was the thing in Visual Basic? You could have a type. Well, it's kind of dynamic. It's effectively a dynamic column, is what we're kind of talking about. Yeah. It's kind of weird, but just
that doesn't affect any of the other data in the column. It doesn't change the status of the column as an int column.
Yeah, it just allows you to do it. So yeah, it's and I have actually found a use for that. I can't remember what it was now, but there is a use for it. Sometimes this dynamic column type can be of use. But indices are created automatically for primary key columns, but indices are crucially important. If you have a database with 500,000 rows in it, and then you do, a table with 500,000 rows in it, and then you say, select me all the records from this table where some column is less than 40 or something. If you don't have an index on that column, the only way it can figure out which records match is to start with row 0 and read all the way through to 499,999 to figure out which ones match. Unless you put an index on it, then it can easily key in, find the ones it wants, bang, and it's really efficient.
I see.
Yeah, very important on foreign key columns, because that's the classical example where you are reading records out of a child table based on a parent ID value. Just a quick word on tools. You can download a command line tool from SQLite.org to read your database and get stuff out. However, most people like to work with a GUI. SQLite.org has a great list of them. I'm not going to recommend one or the other. There are a whole bunch of them. I tend to use SQLite Studio. I like that one, but there are a whole bunch of them that you can choose to find the one that works for you. These allow you to open a database and interrogate it and try queries out and look at the schema, and it's a very useful debugging tool. There is a catch for that. Oh, this is a useful debugging tool. Mm-hmm. The catch is, of course, that they don't work for a database that's on a phone.
Right.
So you need to transfer it from your emulator or from your emulator or from a real phone, and you need to do that using a tool of some kind. And at the moment, for Windows Phone 8.1, the tool we have is the Isolated Storage Explorer tool from the Windows Phone SDK, which comes with the SDK. And you run up a command prompt and you use a command similar to the one shown there, ic2.exe, take a snapshot. TS means take a copy of the local storage. XD means the emulator. You can use D for a real device. Then that long GUID there is the project GUID. You find that in your Apex manifest or in your WMApp manifest. You just run up the manifest editor, you can find it. And then for the TS, you need to put a folder on your PC where you want to copy all those files down onto. So that's the kind of syntax for copying stuff. There isn't a GUI that I know, unless you know. Have you heard of one for Windows Phone 8.1 yet?
No. My question for that was actually somewhere along the lines of, would there be, that you know of, and I'm speaking from ignorance here, a way to store that database on an SD card now that we have SD cards? Because if you did that, you could do it, you could eject it, and then you could use any of those normal tools to interrogate that database. For debugging purposes, at least.
Do you know, there needs to be a new slide in this deck. I hadn't thought of that one. Yeah, great idea. Yeah, that would work. Okay. Yeah, absolutely. Yeah. Now, I could show you that, but actually I was just going to do what you showed on the slide there. So,
no, of course.
So, so I think we'll kind of skip that one.
All right.
Which actually brings us to the end of the day's fun today. So I couldn't show you everything I really wanted to on that, but the app does share code between a Silverlight, a phone app, and the Windows 8.1 head. We'll as soon as all the bits are in place, which should be very soon, then we'll be able to extend that all up to Windows Phone 8.1 as well. That's it for us today. Could you please, we would ask of you, if you wouldn't mind, to fill in the survey and let us know how we're doing. Give us your feedback. We really would appreciate that. Matthias and myself are going to stay online for a little bit. If you've got any few questions, we'll be very happy to answer them. Thanks very much for staying with us, especially if you've been with us all the way through from yesterday morning. Yeah. Tomorrow, we've got some sessions just to wrap this up. We've got the tool session, which if you missed, and we're expecting that now, we do apologize. We're running over, so we're just going to bump that off and start with that tomorrow morning. And then we've got a session on... what have we got a session on?
We've got a session on Silverlight. We have a session on building universal applications.
Yeah, and the store.
And the store.
Yeah. So please join us tomorrow for the end of the Windows Phone 8.1 Jumpstart. Thanks very much.